Hello, my name is Brian Dyck. I'm a software engineer, and this is my YouTube tutorial series on solving the HackerRank interview preparation kit problems. Currently, we are going over dictionaries and hash maps, and this problem is the frequency queries problem. It's considered a medium difficulty problem, and it has about a 63% pass rate. So I'm just going to zoom in here a little bit to make it easier to read. There we go. Okay. So you're given Q queries. Each query is of the form two integers described below, 1 and an x. Insert x in your data structure, 2 and a y. Delete one occurrence of y in your data structure, if present, 3 and a z. Check if any integer is present whose frequency is exactly z. If yes, print 1, else 0. The queries are given in the form of a 2D array, queries of size q, where queries I sub 0 contains the operation and queries of I sub 1 contains the data. Example, queries equals 1, 1, 2, 2, 3, 2, 1, 1, 1, 1, 2, 1, 3, 2. The resulting operations are array of 1, output nothing. We now are removing a 2, so our array is still just 1. We're checking to see if there is anything with a frequency of 2. There's not, so we output a 0. We have a 1 and a 1, so we're going to add another 1, so we have 2 1s. We're going to add another 1, so that's 3 1s. We have a 2 and a 1, that means we're removing a 1, so we have 1 and 1. We have a 3 and a 2. We want to see if there's exactly 2 occurrences of every number. There is, so we output a 1. So this returns an array with an output of 0 and 1. Complete the freq query function in the editor below. Freq query has the following parameters. Int queries q2, a 2D array of integers. Returns int array the result of the queries of type 3. Input formats, q is less than or equal to 10 to the 5th. 1 is less than or equal to x, y, z, which is less than or equal to 1 billion. All queries I sub 0 are going to be 1, 2, or 3. And all queries I sub 1 are going to be less than or greater than or equal to 1 and less than or equal to 10 to the 9th. And then it gives us some sample outputs and inputs. I think this up here probably describes it the best, though. So I think we have all the information we need to go ahead and get straight to the problem. I'm going to go ahead and make this full screen, pull this over this way, and let's go to the problem. So we have our function here, freq queries. So when going on a problem like this, we are quite obviously going to need to have a switch statement in place. We have 3 different conditions. So our first condition, so let's grab that. So for each vector of type int, we'll call this a query. In queries, so we're going to have each of these. We're going to have an int type is equal to query sub 0. And then we're going to have a switch statement that switches on the type. Switch on type. And we have 3 cases. We have a case 1, case 2, case 3. Because it has to be one of those. So here I'm just going to put in a break for each of these real fast. All right, so we know that we're going to have 3 different cases, and we know what we have to do based on this behavior here. In one, we're going to be inserting the data. On the other, we're going to be removing it. And then on the third, we're going to be checking to see if it's there. Now, we can have up to 100,000 queries. That was given in our parameters here on the constraints. So since we can have up to 100,000 parameters, if we have to, at the end, search up all of these calls of 3 up to 100,000 of them, then that's going to take a minute to go through and make sure that we don't have anything. So on any count. So I think one thing that's really important to do early on is to establish two different vectors that are going to be storing, or two different types of unordered maps, sorry, that are going to be storing unordered map, storing data based on our needs. So the first one is going to be, well, they're both actually going to be of type int. But the first one's going to be our val counts. So our value counts, how many counts we have of each value, where the first number first equals the value, and second equals the count. So the first number is the actual value that we're looking at. The second one is the number of that value we have. This gives us a constant lookup time for every value and a constant lookup time to see how many we have of that value. The second unordered map that we're going to want to look at is our unordered map of type int, comma int, frequency counts. So this one, the first number is going to be the number of occurrences of a given frequency, or sorry, the frequency. Let's see here, frequency amount, I guess would be the best way of putting this. And our second is equal to number of them. Number of frequency amounts. And I know that doesn't all fit, but basically what I'm trying to say here is that first value is the number of times that we have, or the frequency amount. So like if we have, for instance, in our counts, we have a value that is 2, we have 2 ones. Well, then here we would have in our freq counts, we would have at 2, we would have 1, because we would have 2 ones, or that's not really the best example. Okay, let's say we had 2 10s. 2 10s and 2 1s and 2 3s. So we have 3 different occurrences of having a frequency of 2. So the frequency amount is 2. The number of frequency amounts would be 3, if that makes sense. That's what I'm trying to say here. I'm not really articulating it the best, and I apologize for that. But that's what I'm trying to say this is. This is our frequency counts, the number of times that said frequency occurs. Now, the reason why this is important is this gives us a constant lookup time to see if, when we get that 3 case, where we have to see if we have exactly that number of frequency of any given number. It doesn't matter if there's all of them are of that number of frequency. We just need to know that there's at least one set of that frequency of occurrences. So this gives us a constant lookup time to be able to say yes or no in that case. Okay, hope that makes sense. If not, feel free to ask any questions away in the comments. I'll try to get back to you and clarify the best I can, but I think it'll become clear once I start coding this. Okay, so now we have our first case. So in our first case, we are adding whatever value we get at query sub 1. So what we're going to do first is we're going to say in the freq count counts at the val counts at query sub 1, we are going to decrement. Now what this means is so currently at value counts of this number, so let's say this number is 1, and we currently have 1 instance of 1, well, that means in our freq counts, under the occurrences of 1, here, this might actually make more sense with a notepad here. Oops, let me make another notepad. That one is my stream notes. So let me make another one. Okay, so let's say we have, this is our array. We just have 1. And let me zoom in on this, make this way bigger. Okay, so we have 1 is our array. So in this case, our count sub 1 would equal 1. Our freak sub 1, so the frequency of numbers that occur once would also equal 1. But let's say we add in another 1. So we're receiving another 1. So we now have an array of 1, 1. Well, count sub 1 is now going to become 2. And freak sub 1 is now going to equal 0. And then our freak sub 2 is now equal to 1. So what we're trying to do is we're saying, hey, we now have, with a frequency of 1, we don't have any of those. We no longer have, that doesn't exist anymore. However, in our frequency of 2, we now have 1. We have 2 1s. So if we have 2 1s, that means we have at least one number, we have exactly one another rather, that has a frequency of 2. So our frequency of 2 count goes to 1, if that makes sense. I hope I'm articulating this properly. But that's why we're decrementing here. So then what we're going to do is we're going to update our counts. So now we're going to say, well, our val counts sub query of sub 1 increments. So we're all this is doing is saying, hey, this value has we now have another of these. Now we have our new count. So since we have our new count, we're going to go into our freak counts, and we're going to say val counts again of query sub 1, and we are going to increment. Boom, like so. So all this is doing is this is mimicking this behavior here. This whole, we went from here, we then are updating our frequency at 1. So our number of numbers that only occur once is now 0. We don't have any number that only occurs exactly 1 time, but we now have a number that occurs exactly 2 times. We update our count and then update the new frequency for this new count. Okay, hope everyone is still with me. So this is our case 1. And after that, we're just going to break, and that looks fine. So now we have a case 2. So under case 2, we are removing a value. So we're going to actually repeat basically the same basic structure, but it's all reversed. So we're just going to copy this and paste. We're going to commit the sin of copy and paste. But I find it very appropriate here. The only thing that changes is now on the count, we are decrementing. So this is just doing the inverse operations here. We lost a 1, so now our number of occurrences of 2 go down to 0. Our number of occurrences of 1 go back up to 1, and the number of count of 1s goes from 2 down to 1. So that's what's happening in case 2. And then our third case is we're actually doing the query inspection. So what we need to do is we need to say, hey, if freak counts of sub query sub 1. So this is the argument passed in with the 3. So if this value is greater than 0, then we are going to say, we are going to want it to add to our array 1. Else we're going to add 0. So we need an array that we can return. So we'll go up here. We'll say vector of int return or ret, and then we're just going to say, okay, let's push this back. So ret dot push underscore back 1 in that instance. And else, if we do not have more than 0, then we either don't have it at all, or we push back, or we have lost it. We are going to go ahead and put in a 0. And then we break off there. And then after we get out of that loop and we've seen all the queries, we are just going to return our ref value. And if I didn't miss anything, that should be good. I'll go ahead and run that and see what happens. We passed all the sample test cases. Now let's see if we're efficient enough. Ooh, we failed some test cases. Okay, so let's see what we failed here. So we failed 3 out of 15. See, and we can't see any of them, so that's nice. Let's go back in, see what we can do to improve here. Let's zoom out just a little bit, because we are super zoomed in right now. Let's go back into the critical section of code, see what we're doing wrong. So we passed our sample test cases. We're failing this special case. 3 special cases to be precise. What could these be? So current values of query sub 1. Query sub 1, okay, that looks right. That looks right. What am I missing? These are underordered maps, right? Yeah, unordered. Unordered. So, okay, let's read through this again. So we have this for each, for query in queries. We're then saying, hey, int type is equal to query sub 0. We switch on the type. We have case 0. Case 0, we go through, do our stuff, then we break. And this is just updating the values accordingly. And that should be good there. Then we have case 2. Under case 2, okay. We missed one small thing here. So in case 2, there is the chance, there's actually a really high chance that the number isn't there. So if the number's not there and we are updating the frequency, we are now doing us a disservice because we're updating the frequency of a number that never existed. And that's not good. So what we need to do is we need to wrap this in a if statement, making sure that at least one exists. So we're going to say if the val counts at query sub 1. So if this is greater than 0, so if this already exists and this is greater than 0, then we're going to do these things. Otherwise, we just break and we ignore it and pretend like it never happened. Let me just fix this spacing because it drives me crazy. Let's run the code. Make sure we didn't break anything. That's always a possibility. Sometimes you go to fix a problem and you end up springing up 10 more. And we have a compilation error. Oh, typo. Typos happen. We wanted clout, or count. Let's see here. Counts. There we go. Run code again. Okay, passing the sample cases. Let's go ahead and submit this code. See if that was our big issue. And we finished. Congratulations, guys. You now can solve the frequency queries problem in HackerRank. So there you have it. That's how you do it. One last look at the code. Basic idea here is we're wanting to have constant lookup tables. That's what dictionaries and hash maps are amazing at. They're able to simply just constantly look things up. They're not the most space convenient, but hey, they offer those really fast lookup times, and when space is not a concern, they are fabulous. We are keeping track of the counts and the frequency of numbers separately so that we are able to look up both on our case 3 and be able to update our counts very fast as well. So if you have any questions as to why this worked, need any clarifications on why this is so efficient, or any other questions, feel free to leave those in the comment section below. Make sure you comment, like, and subscribe if you like this kind of content and want me to keep on producing more. And yeah, I plan on hitting more HackerRank problems in the very near future, so stay tuned for that. Bye for now.